welcome to a new fascinating episode, I suppose. Well, experiment. And what I'm having here is this circuit from internet, of course, but I redraw its output to a Mosfet transistor, and the transistor is here. So everything you see here in this circuit is for driving this transistor, which in turn is driving the motor and the LED, pretty much. Okay, simple. And I'm turning on the power supply, which is 12 volts. There it is, 12 volts. Is drawing. I'm not sure you can see very well. Well, actually, I should do it like this. So let me turn off some of the lights, and you will see better the LEDs. Right now, how is connected? Yep, it's good. It's from this 555, which you can see it here. There. Let me point with my trusty knife, which is metal, and it's perfect. So now I'm holding my knife on the 555. You see it there, under a couple of wires. And I didn't hook up my my oscilloscope, but usually when I did all these tests to figure out if the circuit is working correctly and everything, I did actually, these are the wires on pin 3, this one, and this is on 0 volts rail. These two wires are hooked up, were hooked up to the oscilloscope to actually see what's going on. And that the red one is my oscilloscope. A09T is called. It's the golden brand of oscilloscopes. If you are poor and shitty like me. But right now is actually working, and if I'm turning it down, I hope you can hear it. The LED is not actually showing very well. Now hopefully you can hear it. Yeah, the LED. Let me film like this. The LED is changing intensity, but very, very slowly. It still lights, and you may think is full intensity, but it's not full intensity of the LED. You see, this is actually the full intensity, almost, or possibly the fullest. I'm not sure. But it's dimly very. It's the technology the LED is built, and is working with very low currents. And that's why it's staying lit when the motor is off. It's still a little gap. You should see it on oscilloscope actually. And it's still not a gap, a spike of 12 volts there, and pack very the longer side of the square wave is on 0, but a single spike is still there, and then another one, 0 volts, and then another spike, and it is like I'm showing you. So the 99% of the current is, or the voltage is on 0 volts, but 1% is a spike, or 1.5. And that 1.5 is actually driving the LED. It's very, very, very low voltage, pulsating voltage. So this circuit is actually creating a pulse duty cycle adjust, it says there. And it's a pulsating square wave what is doing, and this is it practically. It's very quiet. I did had a lot of problems with this capacitor here. Where are you? Here in the schematic, here, this guy. It was originally this circuit when it came, I think is still here. Yes, it says there 10 nanofarads, and I changed it with 1 nanofarad. It is the only single thing that I changed. And the circuit was for 9 volts, but I actually use it for 12 volts because the 555 is up to from 3 volts, working from 3 volts to 32 volts. So 12 volts is just fine. And that one I had to test a lot of capacitors actually there, because it was until I reached this 1 nanofarad, and as you hear it, I hope you can hear it. It's very, very quiet, and it's extremely quiet actually right now. But before it was creating a noise, like bzz, bzz, very high pitch noise, a very annoying, extremely annoying sound. The motor, because those spikes were at different intervals from these capacitors, and I changed it. Actually, I changed it to 1 picofarad. It was extremely low, and I think it was still doing some noises. I'm not sure. But this is like not too low, not too high for this particular motor at least. So I changed this capacitor only for this motor. And now I want to show you a secondary circuit. This one here, not this one. So this one, only in here. It's practically a resistor, a potentiometer here, with a resistor, and I had to play a lot with this value to find the middle ground. And this resistor, this potentiometer actually is drawing the gate to the ground, is directing, is grounding the gate pretty much. And this 6.2 kilo is actually giving a positive value to keep it open, and the ground will close the transistor. So okay, let me switch to the other circuit, which is there, this little section here. And let me think what I did. Okay, this guy is out, and it remained on maximum right now. It's having absolutely no effect. And this guy I believe is directly on the gate there. Alright, so if I'm changing the potentiometer, and the LED should work. Yes. You see, this is full range actually. I hope you can hear it. Yeah, you see it stopped. The motor is stopped. The LED is flickering because it's influenced by the motor. Is in parallel with it, as in the schematic I showed you. This is full brightness. But the thing with this circuit, is it's I want to say it's better than the PWM. This is the PWM circuit with the 555. But is having a good side and a bad side, and this is I hope I can draw with let me put it here and focus somewhere there. I hope you can see it. Huh? Can you see it? Yes. So for this circuit, this is the potentiometer range, and I calibrated pretty much to work from here to here. This is the range of the potentiometer that is actively switching on. This is maximum on, and this is maximum off here. And between is actually lowering or heightening the voltage. Is in between voltages to the ground. Actually, it's everything is bringing the gate to the ground pretty much. This is the idea. And but here is still on, and here is still off. So we have a very small range of turning. It's better than I said. It's better than with the pulse width modulation PWM circuit with the 555, because it's actually having an off, physical off. This is how it's looking. The PWM one is off. Is still having some spikes, and vice versa. So 0 volts and 0 volts, and this is here. In the top of the spike is 12 volts, and vice versa as well. This is 12 volts, and everything is on a spike to 0 volts if it's full on, and this is full off. But it's not actually full because it's still having those spikes, and the LED is still showing me that it's having something there. But this with this circuit is full off, full on, and it's much more fine. It's a fine uninterrupted. It's a finer adjustment, and it's better for the motor. While these spikes will brute force it. Pretty much it is shocking the motor, like tuk, 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 tuk. And those coils in the motors are doing something like this. Tuk, 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 tuk. While with this circuit that we have here, passively drawing the gate to the zero rail is just is is fine, is finer, is easier for the transistor. Actually, I didn't show you the transistor. I will show you right now. This is the transistor actually. It's a semi-D transistor. I will not touch the gate too much because usually they are sensitive. They have sensitive gates, and this is the gate. The second pin here. The first pin here is drain, and this is source. The source of electrons. And I hope I am. Yep. The LED. Yeah, it's having a little bit of play there. This is, as you can see, I have to now it is blinking because it's affected by the coils in the motor. I still have a diode there, but it's there, here. But for flyback, to not let the reverse, but something is still coming back and affecting that guy. Okay, so this is the case for this. Actually, this is the first circuit. This was the second, and I didn't like it at all. Because it was having two buttons, and I had to guess when the motor is at middle, when is full even, and it was definitely off. But it was taking a long time until was getting off, and I wasn't. It wasn't decisive as a potentiometer. When you turn the potentiometer, you know exactly. This is, like here. From here to here, and that's it. It's decisive. You know exactly what you will get. But with the buttons, shit is shit. Well, in some applications is nicer, but for me, for this application that I want to use it, and that reminds me to show you probably why all this is for this. It's a blower, it's a heat blower. Hopefully it will come to life, and I will drive this motor here. You see it? I can take it out actually here. And come on, there it is. You see it? It's having a hole here, and this will blow the air, and here inside is what is called heating coil, and it will blow the hot air pretty much. And it's a very, let me put it back, it's a very old project, and I stagnated with it for years actually. I just leave it aside, and I didn't stay with that project, and I built it very hard and very slowly, and I did a lot of mistakes. That is possibly a blower. It was broken, and I discompleted, and I think I will. It's a blower motor for this project with the heating gun, and this was a failure from when I learned, and I learned to actually what I learned from this is to continue even if it's broken. And this guy that I built here, yeah, we are going sideways right now. This guy broke like 12 times. It broke. That guy broke only one time, and I leave it alone. I leave it aside. But this guy that I built here, it had 12 or 15 breaks and I continually repair it and build it. Okay, this is it for this part. Hopefully this guy is still running here. All right, thank you very much for watching, and here very quickly, here I'm building the PWM circuit. Where are you? This is it. This is the circuit, and this is starting. That's the 555. Yes, my time is on the camera is off, and this is a board, which actually is here. If you can see it very quickly, that's it. Here. So yes, so this is the circuit that I will build with the 555. It's actually that one, and all the connections, and it's a scale of 1 by 1. It's the actual size of the components, but pretty much this is 1 by 1 circuit, as you can see there. See? And all those squares, big squares, are pads, and let me grab this guy here, and this is also 1 by 1, but more modular, and this is how it should be. It's exactly as you can see it here, but here is more complicated because I integrated the wires, the connections, and also the other components, but pretty much is the same thing. And you can guide yourself for the plus and the minus. Big pads here, and this is the chip, and I have this little weird thing that I have to make. Get out this guy here. It's a very weird pad, and this one is very weird as well. Usually I don't stay and cut them like this. It's very hard to do, but for special reasons, especially when I have very small legs, I have to do it. And usually I'm doing it like this, with a C, like this, you know, and put it there, and then bend the legs underneath, and that's it. And okay, let me show you how I'm making it actually. And let me make the post here. This is the post for the phone. 2 pieces of wood. It's very simple. I like simple things. Simple and practical, you know. So I've already prepared. Always be prepared. Always. I've already prepared the solder. I pre-solder it. Where are you? With solder. And those little black marks there are actually this thing. It's called resin. It's a resin, hard resin. Actually, it's called sakız in my language, but it's used for violins, for the strings. But this is not for violins, of course. It's a little cube, like that, and they use it. But this is especially for this is specifically for electronics. But it's the same ingredient. It's the same thing. So what I'm doing, you can see I have already the bent legs. I hope you can see it. And this is focused. I didn't check that. Yeah, it's looking like it's focused. It's okay. Actually, let me refocus it right now. Yeah, excellent. Bravo! And I'll take this, put it aside. I will only show you the first pad. I've already prepared here everything, and this is, I hope you can see it. It's far away a little bit, but let's see. If I'm doing like this, it will be good. And I'm pinching making small holes. It's almost like marking. Yeah, you can see it on the other side. And now I will enlarge this very small holes. You see the needle, yeah, the needle got out on the other side, and this is how I'm doing my boards, my cardboard boards. By the way, this is a piece of cardboard, and here is from where I cut it. You see it from there, and yeah, it's very time consuming. You have to be very patient. But I learned to get used to it because it's very practical and you don't have to pay anything. Especially in capitalism, where you have to pay for everything, for every shit. And I don't like every shit to pay. Does that leg going through that? It's not the best tweezer, the plastic one. I'm always using the metal one, but come on. Usually it's very easy to insert. It's more easier than this one here, but this is a piece of copper this time. I usually don't use copper because I don't have it that much. I use this nickel coated, and this, because it's a copper, it's very easy to bend and to here it got into it. And now I have this guy here, and I have to be extra careful with the copper foil because it's pretty much like a foil. It's not that strong, and it will bend sideways, not as I like it. And hopefully, this is the special guy here, but it will get. I got it. So pretty much is there. Pretty much is the same shape. It's not perfectly the same shape, but it's there. And now what I'm doing is very simple. I'm bending those ears away, back, and that's it. That's it. It's but the but it's a ton of work doing all these pads is kind of, it's not nice. And it's not easy, but is giving me a very good result. This is the piece of copper that I cut from this guy. Again, I'm not using copper. It's very rarely and very special, for very special occasions. And this is special occasion here. And I wanted to show you how I'm building a board, a cardboard circuit board. And this is how I'm doing it. And it's very easy, very practical. And if you don't insert it in water, if you don't play with water around it, it's absolutely fine for everything else to have it. Not outside, of course, only inside. But for me is exactly what I need it for. And is not for everything, to use it everywhere. On building this kind of circuits on cardboard is not for everywhere or every weather. It's only for specific weather, inside weather. So yes, here I have another pad. This one I started, but then is also bent, is also prepared. I want to show you because it's cute. And yes, this is it. Yes, this circuit, like I said, is exactly this circuit here. You see it? It's from here. And I'm pretty much, this is it. This is my punching cardboard. And my needles. Also on a cardboard. Because it's practical. That's why. And yes, this is it about how to make my board. Okay. So I've decided, I have decided to show you a second, the second pad, because it's having a very interesting shape. I've already punched and cut accordingly to the size of this pad, and I prepare it. Always be prepared. Always be prepared. And this is how it's going in. I didn't punch it yet. I mean, I didn't put it. This is the first time I'm punching it. Are you going? Yes. It appears that is going something. Like I said, this guy is copper. It's very bendable. Yes, but look how cool it is. The shape of it, like tuck, you know. And this is how I'm bending it. I hope it will not connect to that. I didn't really look on all possibilities, but it's not connecting. It's having a small gap, which is good. Now I'm pressing it, and this is it. Putting it here is the fun part. Trust me on it. Making it is nobody likes it. But here is how it will look. I hope you can see. I'm not sure how well you can see. Yes, it's perfectly the size of the leg. the distance the distance is exactly the distance of the width of the leg of this chip. The width of the pad, I mean, the shorter, this smaller is exactly the width of the leg, which I didn't plan it to be perfect. I was hinting to be somewhere in the ballpark, to be close enough. But it is excellent. That's why I wanted to film this. And by the way, this is the first. If you want a module here, and then the next modules, I didn't make them yet. This is the first take. I don't know how I will make them, how they will look. But this is how I start everything, and it's very progressive in the sense that I will resolve the problems as I go, pretty much. If I will have some problems here, I will resolve the problems as I go, and this is how I'm building my circuits and how I'm prototyping. And everything is drawn by hand except this thing here, which also is having some of my scribbles by hand, and also this by hand. Everything is by hand. Yes, thank you very much, and this is it for this little detailed track or pad. I want to show you this little marvel that I built here. I'm filming from multiple sides or angles to show you that all the pins are on those pads at the limit that I could make those pads, and they are pretty damn good. Don't you agree? I think you should agree. The IC, the 555 integrated circuit, is not soldered yet. I can move it very quickly from there. But I wanted to show you how the pads, well, at least the come on, how everything is, how well it fits. And it took me a lot of patience. You cannot rush anything. And yeah, I will not put it with a phone in my other hand because it's almost impossible. I still have other two pads to put here, so it's only around the chip, and from the other pins I will drag some wires, as you can see from the circuit here. Let me point with a needle here. So from here, from pin 4 to pin 8, it will be a wire. From pin 2 to pin 6, it will be a wire. And from pin 6 going there, another wire. So that pin will float, will not have a pad. Here I inserted another pad, which is not here in the schematic. And from pin 3, which is also in air, is going a wire outside. So these are the, let me try to put it back with one hand if I can. It will not be perfect, but I will try. It's not there, I suppose. Yeah, so it's enough to show you that pin 6 here is it will have a wire first, and pin 3 from here it will be the output of the 555, and it will go there somewhere, and they will remain floating, and it's enough on the corners to have, and also on pin 7 there, which will have multiple here resistors. So from pin 8 basically to pin 7 a resistor, and from pin 7 to other pads another resistor, and so on, exactly like is in the circuit there. Come on, focus, motherfucker. You see, pin 7 is this resistor and this resistor, and then continuing to other shit. Okay, so this is it. I wanted to show you the how everything is fitting, and I am, well, it's not a surprise for me because I did this kind of things multiple times, and but hopefully and probably you will be amazed what can you do manually. Actually, that's what I'm showing you here. What can you do manually? And you can do a lot if you want, if you have patience, and if you really want it. And I really want it. All right, this is it for this part.